Welcome to Global Future School. Students, this is your first year chemistry class. I am Dr. Jalwano, and the topic for today's discussion is the last topic from chapter 3, and that is difference between metallic solid and covalent network solid. Students, we will discuss the properties with the help of different examples between metallic solids and covalent network solid. In previously, in the previous lecture, we have discussed types of solid that consist of molecular solid, metallic solid, ionic solid, and then covalent network solids on the base of their intermolecular force of attraction and their examples. But in this topic, we will discuss the difference between metallic solids like metals and covalent network solids that are giant covalent compounds like diamond and graphite. First of all, what is metallic solid? Metallic solid, they consist of infinite array of bonded atoms. In this case, bonded atoms are arranged at an infinite. There is no limit of this arrangement. They are just arranged in 3-dimensional x, y, and z axis. And in each metallic solid, each cation. Now, what I am saying is cation. I'll just let you know. In each metallic network solid, each cation in a metal has a high coordination number, 4 or 6, but mostly 8 or 11. Coordination number, students, is the number of partially filled atomic orbitals. In metals, the valence electrons can easily be removed and they are delocalized they just form a cloud in the network in the metallic solids. So that's why, because the electrons are removed and remaining atoms are just positive ions, that's why I call them the cations. And these electrons are delocalized. They just form a cloud and thus they move from one space to the other space. And due to this free electrons, metals are good conductor of electricity. As for example, sodium metal, zinc, iron, copper. Copper metal is used in the wires. This is the important use of copper. Like gold is also used in jewelry. So they are good conductor of electricity due to presence of free delocalized electron. For example, like this is a metallic solid, this is a metal atom, but I told you that due to free electrons, valence electrons can remove from their valence shell, and mostly metals, they have coordination number. Coordination number is that how much they have partially filled atomic orbitals. So that is 4, 6, and up to 8 or 11. So these electrons just remains in between them, and they have just a delocalized electron system and form a just cloud. And due to their free movement, they are good conductor of electricity and heat. And the copper, for example, this is used in the wires. So this is shown the sum of delocalized electrons. So that's why the remainings are cations, and these electrons are freely movable in between them. So these are the properties of metallic solids. And what is the covalent network solid? Solid that consists of covalent bond, that is formed by covalent bonds, and in this they consist of infinite. It is also again not limited to some extent. This is infinite arrangement. Array means arrangement of bonded atoms. Like in this case, no individual molecules can be distinguished. You can't say this is from this atom to this is a one molecule. No, this is extended in 3 dimensions, x, y, and z axis, with forming covalent bonds again and again and again. And a given piece of network solid may be considered a giant covalently bonded molecule. For example, diamond. If you have a smaller piece of diamond or larger piece of diamond, so that is a giant network, covalent network. This is not limited. You can't distinction that this is just a one molecule. So these are networks that are formed through covalent bonds. And network solids generally are poor conductor of heat and electricity because they do not have free or mobile electrons. All the electrons are involved in the covalent bond formation. Generally, they are poor conductor of heat and electricity. And strong covalent bonds among neighboring atoms throughout the structure gives these solid. strength and high melting temperature. So due to giant network, due to covalent bonding with the neighboring atoms, they are strong, they are hard, and they have high melting temperatures. Some of the hardest substances known as covalent network solids are like diamond and graphite. So diamond is the hardest allotrope of carbon. Allotropes means different solids that are formed from the same element, but they have different arrangements, like coal, like graphite and diamond. They all are formed from the carbon, but in diamond their arrangement is different as compared to graphite, and this is different as in the coal. So these are the allotropes of carbon. So in diamond they have the covalent network structure, and diamond is so hard, and it is a giant covalent network that it sublime, that it convert into vapors at more than 3500 Celsius temperature. This is like carbon. Carbon is like array attached to other carbon atoms, like tetrahedron shape, and this shape extended x-axis in y and z-axis. So there is no limit of this extension. It extended as long as it formed the carbon atom. So these are giant network covalent network solids. And they also arrange in such a way that they form balls like fluorine, and they also carbon arranged in such a way that they form the carbon nanotube. But these are giant covalent network solids. And next is the allotrope of carbon, that is graphite. Graphite is little softer allotrope of carbon, and it has 3-layer structure as shown in this diagram. Like first, these are carbon. These carbon are arranged like a hexagonal structure, like this hexagonal. All these are hexagons. So these are layers in which carbons are arranged in a hexagon. 1 layer, 2 layer, 3 layer. And these layers are held together through weak bonds, and some of the electrons are available between these layers, and due to this they have directional conductivity of heat and electricity. So electricity can pass through one direction but not through the other direction, because in this direction electrons are not available for conductivity. So they are, graphites are little poor conductor of electricity. And similarly, one of the features that that distinguish covalent network from the metallic network is the coordination number. Covalent network solids, they have low coordination number. Like carbon has 4, maximum it is 4. In silicon also has 4, while oxygen has 2 coordination number. In quartz is actually a solid network, covalent network giant molecule that consists of silicon dioxide like this, and in that case oxygen can maximum form 2 bonds. Now we have this exercise overview. Most of the questions we have discussed in the topic, and we will just give a quick review to the exercise. First of all, you have to solve the multiple choice question from chapter 3, and also try to create new MCQs from the topics, and each question MCQ, each multiple choice question will be of 1 mark in your exam. This is a question. Read the given table below and answer the following question. First table is like this is the 242 is the bond energy of Cl2. This is the calculated bond energy of hydrogen chloride. This is the observed. We have also calculated this in our bond energy topic. This is for iodine I2, and this is the hydrogen iodide calculated and hydrogen iodide observed. So give reason for the difference in calculated value and observed value. First tell the steps how to calculate the bond energies of the compounds, and then observed values are observed with the help of experiment, usually by calorimeter, and then give the reason why there is difference. The difference is due to difference of electronegativity and stability, bond stability. Bond is stable due to difference of electronegativity and more force of attraction. And then question is effect of high bond energy in bond length, with reason. As the bond length decreases, bond energy increases. because greater energy is required to break the bond. Similarly, ionic character on the base of bond energy with reason. More of the ionic character, more of the bond energy, and less the ionic character, less bond energy. And ionic character increases. We have calculated for the hydrogen fluoride the ionic character. You can calculate for the HCl as well as HI. So as the ionic character decreases, bond energy decreases. Ionic character increases due to more difference of electronegativity. Then they require high energy to break the bonds, so they have the high bond energy. Energy of question 3 is energies of the orbitals can be explained by molecular orbital theory. Yes, we have discussed in the topic of molecular orbital theory. It has been observed that in case of nitrogen molecule, sigma 2px is higher in energy than pi 2py and pi 2pz. It's like told there that the energy difference between 2s and 2px is lower. As a result, they intermix to form the hybrid orbital. P orbitals attain the s character, and s orbitals attain the p character. So the sigma 2px becomes a little unstable and at higher energy, while pi 2py and pi 2pz they got the s character, they are at little lower energy. And draw the molecular orbital diagram of nitrogen molecule. I draw the and we discuss the molecular orbital diagram of nitrogen as well as its ions, positive and negative ions. Its B part is give reason. This reason I already explained you. This is the repetition of the question. Then question is carbon can make a bond. We have discussed this in our the lecture, the previous lecture. Carbon has triple bond, and each carbon form a hydrogen with hydrogen 1 bond. And why bond energy of CH is same, although 2s and 2p orbitals are involved. Basically in this, due to hybridization, there is sp hybridization, and the bond of hydrogen 1s is with sp, not with p or s. So these bonds are same. And now also draw their hybridized molecular hybridized diagram, and tell about what type of hybridization is, what is its shape, and like linear, and also discuss about its bond angle and the types of the bonds, sigma bond and pi bonds. And question 5 is molecular orbital theory can explain the magnetic character of oxygen. Oxygen positive, negative, evaluate it. I have discussed the molecular orbital diagram with reference to the paramagnetic and diamagnetic. You know, oxygen is paramagnetic due to presence of partially filled atomic orbitals, but if it is a 2 positive or 2 negative ion, then this is diamagnetic because there is no more partially filled atomic orbitals. So draw the diagrams and discuss with the reference to the magnetic character. Melting point, boiling point, heat of vaporization and heat of sublimation of electrovalent ionic compounds are higher as compared to those of covalent compounds, argue or discuss. So this we have just discussed in the immediate previous lecture. Dipole moment of HCl is given, and the distance between is also given. Percentage ionic character you have to find, and this distance is in picometers. So you can write 127 10 raised minus 12 meter. So 1 picometer is equals to 10 raised by minus 12 meter. And you know its formula is dipole moment formula is this charge into distance, and we have discussed for HF already. Differentiate between a sigma bond and a pi bond. So this is already discussed. Features of the sigma bond, features of the pi bond, and also the in bond energy. The question 9, double bond is stronger than triple. The single bond and triple bond is stronger than double bond, because in double and triple bond pi electrons are involved, in double 2 pi electrons, and in triple 4 pi electrons. So that's why more force of attraction and higher bond energy. So this was all about the metallic solids and covalent network solid, their comparison with reference to the example, and next we will start our new chapter, that is chapter 4.